So let's start now. Okay, so again, some of you already have given me the exam papers. This is the book that asks you not to use highlighter. Yeah, lor, I also thought so, but remember there were a group of you who told me can. I like your picture here, Giselle. Anyway, let me go and ask a friend later on, okay, just to confirm. So highlight using only pencil. So use pencil to do annotation. It is important. Some of you, I have already informed you personally that you need to annotate. Okay, underline the important points, annotate what you need to look out for. Okay, so continue to do that. Now, those of you who have given me your exam papers, right? Okay, Tersing, are you here, Tersing? Tersing, I need to know what is your school name. Can you type into the chat and let me know so I can update accordingly? All right, Tersing? Type into the chat. Okay, let's see. Who did not turn on the video? Pranyush, Jia En, Raha, okay, Le, Sing, Tamai is here. Okay, good. So the rest of you have. Thank you so much. Okay, so yeah, that is important to me. Let me just quickly make a note here. Okay. All right. So those of you who have submitted again, I have prepared the answers for most of the papers, but not all yet. Okay, I'm still in the process of doing so. So you should have received some exam papers to practice on. Okay, if you have not, then can you send me your email address? I think Tersing, you need to give me your email address. Okay, so just now I already privately messaged some of you to get the email address, right? Yeah. So Matthias, I have received part of your paper, right? Yeah. So if you can give me another one, then I will actually be able to share with you the whole list about, I think about 9 or 10 exam papers already. Okay? Yeah. So Raha, you need the link, is it? Yes. Okay. I should have it. You check whether you are receiving this from me. Okay. Try again. All right, so let's go to our worksheet for today. Okay, so this is mock exam paper 2, and this is part 3. Part 3 for this mock exam. Okay, that means that next week we will have our last part for the mock exam practice. Now, can you see my screen? Are you able to see my screen? Give me a thumbs up if you can. Yeah, very good. Thank you so much. Okay, now let's start with the questions here. Very few of you practice this. Okay, I don't see many submissions. So far, I have submission from Avril, Brian, Yun Shen, Emma, Evan, and Vinoli. Rachel, yours is like halfway only. So you need to update your answers or let me know what is happening here, okay? Can Rachel? Yeah, because I don't see your answers appearing. So that is a little bit weird for me. Okay, so later on you just update. Because it's all blank. I can show you later how it looks like on my screen. Okay, so first question. Now, there are actually some questions that I want to talk about. Okay, some of you are busy. Okay, now, let's look at question 1. There should be no problem for question 1. Am I right to say that? What is this topic on? Okay, you look at the question, you must be able to tell what topic or what concept is being tested. Hi, Tamai. Good, Rachel. Yeah. Janelle, you did it? How come I didn't see it? Later, let me try to download. Do you just do it before the class? Okay, This is on materials. Yep. And then on Saturday, remember the intensive revision, we were going through materials, right or not? Okay, so under materials, of course, we talk about the different types of properties that we are exploring. One is strength, one is flexibility. What else? Able to conduct heat, able to conduct electricity, right or not? And then any more that you can actually come up with. 5 o'clock, a few days before. Janelle, that is weird. I need to feedback to the tech team. This is not the first time it happened, right? Yeah. You usually do earlier, what? I mean, okay, let me feedback. Okay, so we learned about flexibility, we learned about strength, we learned about whether it is waterproof, whether it can float. Okay, so yeah, other properties we cover on Saturday, we actually remember listed down inside the slides, right? So other than strength, flexibility, waterproof, okay, whether it's magnetic, you can test it out. Okay, and then yeah, the rest are repeated. So conductor of electricity. Then conductor of heat. Okay, whether it floats. Okay, what other properties are you familiar with and I have missed out here? Anyone can give it to me. Okay, if not, then we can add on the list the next time. You've done the questions already, Rachel. Okay, I believe so lah. Okay, so these are all the different properties or characteristics that we need to know about materials. Now, in this amusement park, people are driving bumper cars. So this part X here, okay, is very crucial because when you collide, how many of you play bumper cars before? I did when I was younger, and it was a very dangerous ride. I almost flipped, okay, because I think the bumper car was not actually built very well. I was very young then. So I think by now, when you are playing, right, they could have already improved on the makeup of the entire vehicle. Okay, so bumper cars, they serve to hit each other, isn't it? So when you actually bump into somebody, what happens? You feel a very strong jerk, right? Okay, you hit the person very hard, and then you probably will be moving inside your seat. Okay, and then your car will actually bounce away from the other, isn't it? So this part here tells you what? It is actually very flexible. What's the meaning of flexibility? What's the meaning of flexible? We asked the same question on Saturday, right? So those of you not inside the intensive program, you must know this. Okay, what is the meaning of being flexible? Yeah, some of you are typing in. Very good. Tamayi, where are you? You don't look like you're at home. Or are you at home? You are in another part of your house. Okay. Flexibility means what? Okay. Ability to bend, right? Okay, without breaking. All right. So ability to bend when it is subjected to a force without breaking. So why is it that it's important for this to be flexible? Because it can bend and then it can go back to its original shape. Yes, without breaking easily. Then we also need this to be of high strength because you are hitting each other with very high impact. So strength must be there, okay? And then it needs to also be flexible. All of you who submitted, you have no problem with this particular question. So you got this right. Let's go on to the next one. Okay, this particular question, you have learned this in P4, okay? Under the topic of matter. So remember, under this topic, right, you learn about solid, liquid, and gas, right or not? So basically, in this case, right, you are talking about the containers. Okay, so Bernice had 2 containers, A and B. Each has got a capacity of 500 cubic centimeters. That is the volume that it can actually contain. So the space inside is only of this volume, right? So she actually fitted a pump to each container as shown. In the first container, which is container A, the plunger actually took out some air. Okay, how much air it is given over here in the info, 100 cubic centimeters of air. Then next one, plunger, all right, in container B, pumped in some water. So this is 100 cubic centimeters of water, okay, and 100 cubic centimeters of air drawn out. What is the eventual volume of air in the container after her action? Now you have to take note. What are they testing you? They are testing you about volume. Okay, volume of air. All right. Volume of air is not fixed. You all still remember that? So the volume of air is actually not fixed. Okay, but the volume of water is actually fixed. Okay, so when the water goes in, right, water will occupy 100 cubic centimeter of space. How much space left for air? Okay, so air is occupying now only not 500, but only 400. All right. So in this particular case here, okay, for container A, 100 cubic centimeters of air was actually drawn out. But what is that space inside this container? It is still 500 cubic centimeters. Air will occupy any space. If I have a small volume of air, which is from, let's say, a syringe, okay, I pump this air all into an empty box. The box is actually maybe 1 liter, 1,000 cubic centimeters. So from that tiny little syringe, which is probably just 10 cubic centimeters, now it is occupying a bigger volume, bigger space, which is 1,000 cubic centimeters. Okay, so it will just fill up the entire box. Okay, so the volume of air has changed. You understand what I mean? So air really depends on whatever container it is in. So long as that container has a fixed shape, then the volume of that container will be the volume of air. Are you all clear? No matter whether I took out air or not, I pump in air, it is forever that space. Okay, so answer has got to be D. So those of you who got this wrong, please be mindful. Okay, air will actually occupy. This is one of the misconceptions that some of you still have. Air occupies any space it is placed in. Okay, so when I transfer air from, let's say, a big container to a small container, the space is occupying is smaller. If I transfer it to a bigger container, then the space or the volume is occupying is bigger. Okay, so it is dependent on that container it is in. Now let's go on. Bob carried out the following experiment to find out which type of soil contains the most amount of air. So if you have more air inside the soil, okay, in this experiment, when you pour water in, the water will take over the space occupied by the air. Is that clear? Okay, the water will take up the space occupied by the air. So he poured in, right? Okay, equal amount of water into the 3 measuring cylinder, and then this will be the observation that he has seen. So out of P, Q, and R, which one had the most amount of air? Okay, which one had the most amount of air in the beginning? It has got to be this. Can you see? Why this? Because originally, there's a lot of space, right? So a lot of air spaces within. Okay, so when I pour the water in, the water occupied the space that was originally air. Okay, that's why what is left piling at the top is very little. Okay, if there is very little air spaces inside the soil, right? In this particular example here, like for example, mud. Mud is so clingy to each other, very sticky, right? There's actually very little air spaces within them. Okay, so if you pour water in, you will see that very little water can take the space inside the sample of soil here and a lot of extra water pile at the top. Okay, so our answer over here, most amount of air is this earlier. Okay, so